Hello, in this video, let's look at how to solve the same system we just solved using substitution, but in this video, let's use elimination. And the answers would be the same, and that's the point. So we choose the method that best suits us, and they both will give us the same result. So when we use elimination, we add equations in pairs in such a way that one of the variables cancels off, either y's or the z's or the x's. And to do this, we can look at all the coefficients in front of x, the y, and the z, and ask ourselves, if these were denominators, what would be the least common denominator? And the letter with the least common denominator is the one that is easiest to cancel. So if we look at the common denominator between 2, 4, and 3, then that answer would be 12. And if we look for the common denominator between 1, -2, and 5, that would be 10. And between 3, 1, and -2, that would be 6. So the z is the one with the smallest numbers, and so when we add the equations and do the math, the smaller the numbers are, the easier it is to do the computations. All of these would work. We can cancel the x, even though the numbers would be bigger. We could cancel the y's if we wanted to, but the z's would be the easiest. So let's cancel the z. And the way we do it is we add the equations in pairs. So if we add the first two and we're aiming to cancel the z, then both numbers have to be the same with the opposite sign between them. So if we have -3, this z should be +3 to cancel. And that means we're multiplying the entire equation by 3 to do that. So if we multiply the middle equation by 3 all the way through, we're going to get 12x minus 6y plus 3z is 27. The first equation is unchanged, so let's copy that over. 2x plus y minus 3z is -4. Now when we add them, we have 12x plus 2x, that's 14x. 1y minus 6y is minus 5y. Z's cancel off. Minus 4 plus 27 is 23. And that's our first equation that has no z's. Now we can add another two equations aiming to cancel z as well. So if we have the middle equation, 4x minus 2y plus z is 9, and then the second one is 3x plus 5y minus 2z is 5, and we're aiming to cancel the z, then both numbers should be 2. One is plus, one is minus, which means we're multiplying this equation by 2 all the way through. So if we're multiplying through by 2, we're going to get 8x minus 4y plus 2z is 18, and the second equation is unchanged. 3x, 5y minus 2z is 5. Now when we add them together, the z's should cancel. 8x and 3x is 11x, minus 4y plus 5y is 1y, z's cancel. 18 plus 5 is 23. That's our second equation with no z's. Now we take our two equations and we continue with elimination. So here they are. Let's copy them over. 14x minus 5y is 23. 11x plus y is 23. Now we can choose to cancel the x's, but we will be looking for the common denominator between 14 and 11, and that is a big number. Or we can cancel the y's. Then all we need is plus 5 and minus 5, which means multiplying the second equation by +5. And that makes the first equation is unchanged. We can copy it over. Minus 5y is 23. And then 5 times 11 is 55x. 5 times y is 5y. And 5 times 23 is 115. Now when we add these two together, 14 and 55 is 69. Y's cancel off. 23 plus 11 plus 115, sorry, is 138. And if we divide both sides by 69, we get x is 2. So if x is 2, then we need to find the other two unknowns. And at this point, we can go back and try elimination again. But it may be easier to actually use substitution, because in this equation, we have the x's and the y's, and we can find the y because we now know what x is. So plugging back the 2 into this equation will make, so there's a 2, plugging in 2 here, sorry, in for the x, I apologize, in for the x, we have 11 times 2 plus y is 23. 11 times 2, that's 22. 22 plus y is 23. Minusing 22 from both sides, y is 1. So now we have the x, we have the y, all we need is z. And to find z, all we need is any equation that has z's in it. How about the middle one? That one is the smallest, has the smallest numbers of the three equations. So let's go back to this and use the answers for the x and the y to get the z. So in this equation, we have 4 times x, which is 2, minus 2 times y, which is 1, plus z is 9. So 4 times 2, that's 8. 8 minus 2 is 6, plus z is 9. Minusing 6 from both sides, we get 3. And so we have the x, the y, and the z. And we write our final answer as a 0.213. And that's the same answer as we had using the substitution. So this is how to use elimination to solve the system of 3 equations with 3 unknowns. If you have any questions on anything, please let me know. Thank you for your time. Take care.